So today I'm going to discuss you about Mastercam Design X5 and how to create toolpath programs using this particular software. So as you all know that it is not possible for us to physically write or make programs, three-dimensional programs which involve different complex contours. So in this regard, I will show you how the basic two-dimensional or three-dimensional toolpath programming is generated using Mastercam Design X5. For this, I'm going to show you how the graphic user interface will be like. So as you can see here, these are the various options that you are finding in the menu bar and in this icon bar. So this is the graphical user interface where you are going to generate our three-dimensional CAD model, CAD/CAM model. And here this is the toolpath tree, and this entire box is called Operations Manager. This is toolpath tree where you will be finding the various icons, where you will be finding various operations that you can perform on various types of toolpaths that you generate in this program. So here is the solids tree where the various detailed operations, wherever the detailed geometries, geometric profiles that we generate in solids are displayed here in the form of a tree. So this is the toolpath tree and this is the solids tree, and these are the various commands. So let's go to the video. So let me start you the video with by generating a rectangular object here. So in this rectangular object, the rectangular object, if we want to, we can start it somewhere from the origin position. So we can directly mention my value of this origin position as 0 and 0, x and y 0. And if I first point here, okay, so here I am starting my 0 point here, and this is here I am going to show you I am going to define this rectangle 500 by some, let us say, some around some 500 square block. Let us say 500 by 500 square block is being generated. So in this, so this is the square block that has generated. So in this, if I am to generate another rectangle, so if I am to generate a solid rectangular pocket, if I am to generate a solid rectangular pocket, then I need to again enter my coordinates 50, 50 and 0. So here this is my workpiece. So 500 by 500. So this is my 400 by 400 workpiece dimension object. So this is my job. So if I place this in the isometric view and go for the fit mode, so you can see the object has been generated like this. So I am going to generate a solid extrude chain command. Okay. So up to a distance of, let's say, some 100 mm. So this is the thickness. So this is the rectangular solid object. So in which I need to cut this particular rectangle, the inside rectangle that has been drawn, that part I'm going to cut it, or instead I would like to generate pocket of 75 mm size. So this is the pocket. If you want to look into the three-dimensional profile of this one, you can have it clicked by using this one. So if you click that particular option, you can have a three-dimensional solid object picturized with surface. So this is the wireframe model, this is the surface model, shaded part, this is the wire gradient part. Fine. Now after generating this one, I would like to generate fillets. So solids, fillet, fillet, and here in this particular area of selection, so there are some series of choice of selection of your objects here. So you can either pick an edge, you can either pick a face, or pick up the entire solid surface. So instead of picking the entire solid surface, I am picking the solid part here. So this is my edge, another edge, another edge, and this is another edge. And apart from that, I again want to pick the face so that I get my rounded corners on all the lower edges of this face. So after this, I would like to provide in what is this, 45 cornered radius object. So this is the part that has been generated by me. Right. Right now, let us copy. So this is our main object. Right? This is the main solid object that has been generated now. I would like to make changes to this object, and instead of generating the toolpath directly on the solid, because it's the solid, the entire processing time for generating the toolpath on the solid object is consistently taking a large amount of time. So instead I would like to, so this is the area of my toolpath. So the toolpath would be generated only in this localized surface inside, that is inside the rectangular box. So this particular pocket is where I require to generate the toolpath. So what I would do is I would consider only these surfaces that are available where my toolpath that is required to be generated. I will be omitting down the outside surfaces of this solid object. So for this to happen, I don't want to change the object here itself, because if I want to come back to this original condition of my work model, I would not be getting it. So I would transfer, I would copy all these different features, all the geometries that I had generated here in this particular level to a new level where I will be copying this one to all entities, all entities. Okay, copy, use main level to level number 2. So we go here. So there is a new level that has been created. So you can write it here as, so main job, and here you can write solid job. So total entities has been copied here. So this is the thing. So you can off it so that any changes that are made here are also happening there. So I would close it. So this is the thing that I had generated here. Now let this level be as it is, and I again want to copy all the solids part, all the solids of this one to third level, so that I generate surfaces over in that level. So as you can see here, I am going to the third level and switching this off, and I am writing this as surface job. Okay, so here it is, surface job that has been generated level 3. So now I would like to change the color of my surfaces to yellow color. So now I would right click on this one, select entities to change the color of. So I would select all solids. Okay, okay, yellow color. So I had already changed it to yellow color, and I would like to delete in case if I find any curves here, lines or curves that are generated in the previous levels. Uh, okay, all that are all total wireframe is being deleted. So okay, okay, okay. This object. Oh, no. So this lines. So I will just change the color of this one to this one. Okay, this is still a solid object. Okay, my mistake. So I would create a surface from solid. After then I'll be able to remove the solid. So create surface from solid. Okay, and I would pick up this solid object instead of face here. So now selected. So delete. So this is the delete option. So I would delete this solid. Okay. So now there is no solid inside, and it is a totally surfaced object. Okay. Now delete all wireframe. So all wireframe models has been deleted. So now repainting this one would fetch me this particular object. Now I would totally copy this particular level to all surfaces to fourth level, where this is the where that will be my toolpath level. So level 4 digital. So this is my rough toolpath. So rough toolpath. So now I would generate curves on all edges on all surfaces. Okay, in red color. So this is my surfaces now, and since my toolpath is restricted to only the inner part of my rectangular profile, I don't need these outer surfaces, because these outer surfaces, if I leave them as it is in the surface, this might lead to increase in my total overall processing time of my toolpath. So I would remove them by placing this in the front view, and in and interior, here I will be selecting this particular thing, and I will be drawing a window here. So this is the object that is required here, so I am placing this particular surface here. Now now what I would do is I need to prepare a boundary for this one. So I would transform or translate some of the curves that for generating my boundary. Transform, translate only lines, arcs, only wireframe. Okay, and the z-axis by, let us say 100. Copy. So this is the, so if you leave this in the front view, you will better visualize it. So clear colors. So I want to distinguish my boundary with a new color. So change color of this one to blue color would be. So I change it to blue color. So this is the object. So you can see here. So for generating toolpaths here, I need to first pick up the machine default type. So toolpaths, yeah, toolpaths. In this surface rough pocket. So pocket milling is being done on all surfaces. Rotating surface will pick up this object in containment chain. So the chain has been picked up. So I'm picking up the parameters here. So this is the processing of your toolpath in the Mastercam software. So it is now programming it. It is now preparing the program. So in the background you can see the compound setting for the tool 97.1%. So this is a toolpath that has been generated. If you check the back plot of this one, so the tool, let's load on this one. So this will verify. So these are the stock corners. -100, you can say this one. Use the speed of this one, you can just check it out. How the program is actually running. and this is the post processor of the or the LC code that is going to be generated. So this is the post processor which is actually preparing the program. Okay, CNC can program for the program that has been made. So this is the program that has been generated. So here you can change the program number of the program. So this is the program G21, G17, G40. So here you can have the offset for height offset. You can have your offset for G. You can add G54 here. So this is G54 code. So you can remove actually A0 from here. Height offset is not necessary. And M03 S2000 H1 Z50. If you require this one, you can have it, or you can just remove it. If you are having your datum coordinates or datum workpiece coordinates in G54, you can mention it definitely here, or else you can have any other number G55 or G56 or up to G59. You can have any G code position here. So this is the total length of the program. You can see here. You can have the total. You are totally defining 5054 blocks of program has been generated using this software.